refer back after the class. Okay. Okay, all right. So let's see the lab sheet. I have uploaded the lab sheet decoder. This, all right. In the you can find in the ulearn. So this is the topic, which is the decoder and encoder, and we will do the simulation. Okay, I have introduced what is decoder, and as you know before, the encoder is the reserve of the decoder. Okay, so as for procedures, okay, in part 1, by using a multi-sim or logi-sim. So this is, I provided the website for the logi-sim, where you can do the multi-sim live, or any suitable software. You need to design 3 to 8 lines decoder based on the 7418138 IC. And then what you need to do is you need to carefully examine the input of from A0 until A7. All right, so this is not A0 to A2. This is from A0 until A7, and then the output, yes, the input is from, because we have 3 input, the input is from A0 until A2, and then the output is from Y0 until Y7 of the 74138 IC before you design the 3 to 8 line decoder. So for this, you need to refer back for, you need to refer back to the previous this, okay, previous the previous slide. You need to see what is the truth table for the decoder 3 to 8. So, and then carefully examine A2 to A0 to A2, and then the output before you design the 3 to 8 line decoder. So you may ignore the enable function of EN2, EN1, and EN0 when designing for the 3 to 8 lines decoder. So for this part, okay, the output when the enable is other than enable 1 and enable 2 is other than 0. So you will have the output for this is 0, all 0. Okay, so this is when what is the mean of, you can just ignore the whenever the enable for 1 and 0 is not 0. Okay, and so part 2 is you need to design, okay, and then you need to verify the decoder operation by setting A2, A1, and A0 to each combination listed in the table 5.1. And then you need to record the output observed, the output observed in the same table. So, but I think you need to have like a different table. First for this part, okay, for B, and then for the second one, for a same IC, the output is only generated when enable input, all the enable input are high. So we know that when the enable input are not equal to 100, regardless for A0 to A1, so you need to design, or you need to create another table. Okay, so for part 1, you will have 2 tables, one for when this condition, okay, the first condition, and then the second one is for C. All right, and I think the first one you will get the output like this, and then the second one, the output will be all are 1. Okay, only at Y0, for example, when A2, A1, and A0 are 0, only at Y0 the output will be 0. This is because the enable here we refer to the 0. Okay, you can refer to I think in this slide. Okay, operator. Yeah, okay. When the active low, the activate output line 0 and the rest are of the output are 1. Okay, when the active high, only at the output will be 1 and the rest are 0. So for the first uh, result in table 5.1, you need to have this active high output, and then for table 5.2, you need to have the active low output. All right. So this is for part 1. Okay. Let's see. And then number D, you need to construct the 4 to 16 line decoder, design and build your circuit and verify the output using the truth table, and you may ignore the enable function. So for A until C, it is the 6 to 3 lines decoder. Okay. And for the number D, you need to create another truth table and then design the the circuit in multi-sim or using the logic sim, right? So for the encoder is the reverse of the decoder, where we have to decode from 8 binary digits to 3 line encoder based on 7414 IC. Kalau yang decoder, we have 74138 IC. And then again, you need to do same procedures as in the part 1 for the encoder, right? Except for yeah, you only need to have one only at enable is 1000. Okay. And so here is not 5.2 anymore, so you will have 5. For number part 1, you will have a 4.1 until 4.3. So part 2 will be 5.4 and record the output observed in the same table. Okay, I would like to demonstrate how can you design the the decoder using the multi-sim. Kalau you ada multi-sim, you boleh guna multi-sim. Kalau tak ada, you boleh guna yang live version dekat logic sim tu. Alright, so here, okay, this is the example of, okay, boleh nampak Can you see my screen of multi-sim now?
Boleh.
Yes, boleh.
Yes. Alright, so this is the example of 3 to 8 decoder, where we have a 3 input here, okay, 1, 2, 3, A, B, C, or A0, A2, A2, A1, and 0, where the C is the MSB and the A is equal to A1, it is the LSB, okay. And then we have a VCC output here, and then ground at pin number 8, and from pin 7, 9, 10, 11, 12, 13, 14, 15 is referring to the output Y0 until Y7 respectively. Okay. So why we put the the NOT gate here, because there in this IC there is, you can see the bubble here. Okay, the bubble is referring to the NOT gate. Okay, kalau tak ada bubble, you tak perlu letak NOT gate lah. Alright, so here I use the digital constant, I think. Yes, this is the digital constant. You can add the component by using the place Control W, and then you will find the under master database all group, and then you will find the digital constant. Okay. Okay, alright. So this is for like the input, okay, ataupun the switch. Either you want to input, you want to set an input of 0 or high or unknown. Okay, so you will have 3 inputs from A0 until A2, and then this is the enable input. Okay, from pin number 5, 4 and 6 is enable input, and then from the truth table, okay, from the truth table, we see that the enable number 2, which is the most significant bit for enable, must be all for all the condition. Okay, so that's why I connect the A2, ataupun kalau you refer for this figure, E3 is 1. So you need to connect to the VCC, right? And others will be 0. Okay, so 0 connect to the ground. Then let's get back to here. So only at enable number 2, enable 1, sorry, enable 2, it is connected to the VCC, and then others will connected to the ground. Okay, you have 3 input here, and then you need to add the probe. Okay, for the output, I just include the probe as a component. So you also can place yeah, you boleh pilih mana-mana lagi whether either you want, kalau kat sini I just write a probe. Okay, and then you can add the probe as the output. Okay, or maybe you can have the bulb or LED. Yeah. All right. So referring back to the lab sheet, verify the decoder operation by setting A2 until A1 to each combination listed in table 1, and record the output observed in the same table, capture the result and paste it in your report. Okay, so regarding based on this table 5.1, we know that when enable is always 100, and then the input is the combination from 000 until 111, you will get this kind of result. All right, so let's check whether you will get the same result using the multisim or not. Okay, so here you can change the value from 0, 0 and 0. Okay, all right, and then when A2, A1 and A0 are zeros, the output for only for Y0 will be lights on. Okay, will be 1. Right, so you can see that here, whenever when input these 3 inputs are 0, the output for Y0 is 0. So you can change this value to see whether you will get the same result or not. So 0, 1, 0 referring to this truth table, 0, 1, 0 at 0, 1, 0, only at Y2 the probe will be lights on. Okay. All right, so Y2. And then another example maybe, when this value are all high, so you will get the output at Y7 will be lights on. Okay, ada soalan setakat ini untuk part 1? Do you have any question?
No.
No? Okay, faham Alright, so next one is the part two where you need to design the encoder and using this 74148 IC. Okay, where to find the IC again? Place the component and then you can just write 741 what uh, and find the what decoder, sorry, encoder. Okay, I will not give the example for encoder. You can find or design by yourself, and then you need to include or to verify the encoder operation by setting the A0 until A7 to each combination listed in your table 5.3. Okay. And now we have the part 3 where you need to simulate the 7-segment display decoder. And you can see here is the show the 7-segment display, and then in B or in 5.4 is the 7-segment alphabet. Okay. You need to design 4 to 7 lines 7-segment display decoder that will only display number 1, 3, 5, 7, and 9. Okay, and alphabet alphabet A, B, C, D until F. Okay, you may ignore the 8 segment of the 7 segment display. Okay, first you need to design by developing the truth table of 4 input and 7 outputs. Okay, so this is the you can get the truth table from the the lecture notes. All right, so from 0 until 9, A until G. Okay, and then the input, you have 4 inputs and with the 7 output. All right, so first start to design blah blah blah, and then fill the truth table based on the required output. So in this required output, I only include from A until G. Okay, but you also need to write the output for the number 1, 3, 5, 7, and 9. And then, for example, input 001 should display number 1 and input 000 should display nothing. So for part 3, you will have two truth table, one for the number for displaying number 1, 3, 5, 7, and 9, and the other table to show the A, B, C, D, E, F, yeah, until F. And then you need to write the Boolean expression for each of the the output for both table. Simplify the Boolean using the K-map, and then draw the circuit diagram using the Multisim or any other suitable software. Don't forget to connect the output to the 7-segment display. Lastly, simulate the circuit diagram and screenshot for each of the results. So for the result, you will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 screenshot of the output. Okay. I have the example for part 3 here, where you need to simulate the 7-segment display in the in the multisim. Okay, so this is how I connect my 7-segment display with the 4 to 7 decoder. All right, so for 4 to 7 pins decoder, you can use the IC74LS47D. Then as for the input, I use because we want to change the value faster. Okay, you can use the the switch as an input. So to place the component for the switch is under the basic, you will find the switch, right? So as for this kind of switch, you need to select the SPDT, right? So this is the SPDT switch, and we need to connect the ground for all the switch here, and then the input to the VCC. And then for each of the 7 segment display, for example, here you have OA, or we have the from Y0 until Y7, you need to connect to each of the 7 segment pin respectively, okay? And then for the input, right, so this is the input for switch A until switch D, and then this is the enable what? The enable input, okay? So for the 7 segment display, you need to enable all the input from pin 3, 4 and 5 is connected again to the VCC, and then the ground will be connected to the ground. Okay, let's see when all the inputs are 0, okay, what will be the output in the 7 segment display. Okay, run the simulation, so you will get the number 0. So as for 1, okay, this is 4. When you have 0, 1, 0, 0. Okay, so this is for the number, and then based on the part 3 procedure, you need to come out with the output 1, 3, 5, 7 and 9. Okay, so please design the truth table first, and then check with your output in the 7 segment display, right? So let's see how about the alphabet. So we know that when all the inputs are 0, all right, so it will show the this kind of result, okay? And so number 9 will be, okay, you can try. We want to what? Okay, cancel. If all the input are 0, you will get 0. For number 9, let's see again. Okay, only at number 1. If you want to display number 9, so you need to have the combination of 1, 0, 0, 1. So for this, you need to have 1, 0, 0 and 1, terbalik 1, 0, 0, 1. So at 1009, it will be the output of 7 segment is 9. Okay, so you screenshot for each of the output, and then paste in your result, in your report. Okay, get back to the procedure. Lastly, simulate the circuit diagram and screenshot. All right, so I think that's all the explanation for lab session number 5. Do you have any question? Semua faham tak?
Faham.
Faham, eh?
Faham.